So this is a new segment, basically. All right, so we're going to go over now just some Linux commands, a new set of Linux commands. A lot of this course is just Linux commands, but it gets a little bit involved as we go forward into topics. So the first big topic is going to be task scheduling, which is be cron jobs, and that'll be also part of next week. Friends is a much more involved thing. Let's go ahead. So let's navigate to the desktop and clear. /L. Now we're going to navigate to ITS 372 Spring tab, and it's 2025. Clear ls-l. Oops. Can't see with this thing. ls-l. I have a bar. Oh, yeah. You guys can see I have a bar. All right, so basics with Python, example of chown. So I think that's what we were doing on Monday, if I remember correctly. And we've just started looking at some commands. So essentially, the homework will just consist of between 3 and 5 problems that I still need to create. I want to think about them a little bit. But let's just go through some of the commands first for today. And it could be some of these problems that I have. I build problems every year. So, all right. So let's take a look. So this is like we're currently in the third week, I think. Hello. So services is kind of the big thing, right? So we're going to look at services. And what that means is pretty straightforward. So I think I gave you the history when I was saying that Linux was kind of being beaten by Microsoft and Windows with their servers, right? You know, there was really no application for Unix at the time or Linux until finally Apache came along, right? And what is Apache is, you know, the web server, basically. You guys all know what a web server is. You know how to develop websites and all that. And it was a cheap solution, a very powerful, solid, very secure, very good operating system in the cloud, or not in the cloud back then, I guess, but you know, a server somewhere on the internet. And it was just people just said, hey, you know, we're serving websites, e-commerce is starting out. So boom. So it became the service that Linux server provided. And that service was provided by a daemon called Apache. And it was serving on port 80. So what we're going to learn about is that, you know, we're going to look at this file here, services, in the etc folder, and we're just going to see that there's common services, and they're all associated with a specific number, which is the port number that you open on that operating system. So port 22, port 80, port 43, and so on. So let's take a look at that. So etc services. So simple, you know, we're just trying to familiarize ourselves with this. So we're gonna actually, my recommendation is always check the permissions. So remember, so etc is a big folder, lots of files. So if you just do ls-l in there, it's not practical. Instead, you can do ls-l /etc. Remember that that's for the root etc. And then we're going to do services. Okay, permission denied. Denied, it says. Okay. Oh, and then I didn't do any command actually. Probably be trying to execute it. So let's do ls-l. There we go. So now we can see the folder or well, actually, you guys tell me, is this a folder or a file? Hmm? All right, good answer. But if it's, yeah, you're right, everything is a file, but folders can also be files. But now, semantically speaking, right, is it a folder or a file? Yeah.
Is it file?
How do you know?
Because it'll be at the front.
Yep, exactly. Yeah, exactly right. So the little hyphen at the front means it's a file. That's what I was getting at. Does that make sense? So we always want to gather information, understanding is pretty important. So we look at the permissions, it's owned by root, we're seed, but we're only reading, we have permission to do it, right? So that's kind of where we're going. This is an etc located file, so it means it has something to do with configurations, is possibly important, right? So we want to take a look. So now I'm going to do cat, which is, one thing I like using to just visualize files. I don't want to edit them or risk editing the file. And you can see basically it just provides a list of different port numbers on the system, like a nice little assigned numbers. You can see it's pretty extensive. TCP port service multiplexer. So what do you see here? So for instance, I don't know all these port numbers. Obviously, there's how many port numbers in the system? It's 65,000, right? Yeah, you should know that. 65,000, right? Port numbers usually, and you have a list. The first 1,000 or so are assigned to important services that all Linux operating systems have. And then the higher numbers are when you start a program that's listening on some random port, right? Your games, for instance. You have a game and you're playing with your friends, and boom, you open a port and it's port 3,000 temporarily, right? So you can do the communication back and forth. But anyway, here we just want to see that, we have important services, SSH. You guys will be using SSH quite a bit, and this service. So the thing we want to know here is what are the services, which ports are open, what service is running on the operating system. Remember that I'm sure you've learned in your security classes that essentially there's device hardening is a terminology, and basically you want to do what? Harden the device, which essentially means closing ports, updating, things like that. All right, so you have SSH port 22, 23 is Telnet, FTP is port 21, FTP data is 20, so you can see the numbers there. So that's essentially what we're doing here. And then, of course, there's TCP and UDP. So UDP, for instance, DNS, right? So you guys learn in your networking classes. One establishes a connection with a three-way handshake. The other one doesn't. All right. SMTP for email, right? Pretty important. So as I said, so if you think about it, SMTP is port 25 is just email, right? And maybe that's the whole purpose of that Linux operating system. So that Linux operating system just, is a server providing the service of email. If you think about it, as I said in the history and back already early 80s, they were basically using these things for computation and email through the university, just on the command line, right? And we'll do a few examples later in the semester when we look at the email service of how that works. It's actually pretty nice and straightforward. Oh yeah, you have a question? These ports are just meant to be there for help, but the ports you can port forward, redirect. Do you know what I mean? So now if you're thinking about that in terms of security, it's not recommended. There's no advantage in if anything think about this. You're the system administrator that handles that server. But what happens when you leave and someone else comes in and now they want to use port 22, but you decided for security reasons, no, that's port 80 now. And you swap them all out. It's going to be hell. You know what I mean? So you don't really, it doesn't provide security really, but these are just assignments that have been done and it's meant to help out because they're the most important services. Well, that's why you have 65,000, I would say. Okay, so the Internet of Things, right? So the Internet of Things would not use port 22 for anything other than SSH, but they can use there's a lot of ports available. So there's I would say if there's 65,000, there's about 1,000 in use. The other ones are open. There aren't enough services to fill up 65,000. But there's a possibility that in the future, here's I'm into AI, right? So maybe they're going to invent a daemon, AI daemon that all Linux servers have. And maybe in 10 years, every Linux has it, just like SSH. And so, and they may designate it port 775. And kids then, 10 years from now I'll say 22, 775 for AI daemon stuff, you know what I mean? So that can totally happen. What they do is they just get together, this committee, and they'll just create standards and they'll say, okay, we're going to designate 775 from now on for this. And they just follow that design flow. All of this is software. Remember, guys, you can literally go get the code. Give me a sec. For the kernel, compile it, and boom, you modify the operating system because it's all open source. Yes, sir. Kerberos is a security thing. It's a security daemon, actually. So you can look it up. It's a good question. Which port is it? 750? Where does that say? Are you not using the Ubuntu? Where does it say then? Where does it say that though, is what I'm asking. After which port? They're port 6. Okay, so you're reading this. New ports, yeah, there you go. So actually, it's what you're saying what we were discussing, right? So it says here, and I think he's reading about this paragraph, right? That's what you're talking about? But okay, so when I did, right. So I'm just saying, where in the etc services file is that? So I can find it. It's not on mine. We have the same. Okay, it might be that you guys have a slightly newer version of Ubuntu than mine, because I didn't install it this semester. Okay. All right, but yeah, so new ports will be added on request if they have been officially assigned by the IANA. So that's what you and I were talking. This is when I said a committee, right? People and used in the real world or are needed by a Debian package, etc. If you need a huge list of use numbers, please install nmap package and so on. But yeah, so this is, as I said, is people. There's a committee that governs this, that gets together, that have standards, if you will. And but there's about 65,000. I don't know that that number has increased. So last time I checked, that was always been the number. And these numbers are assigned like that. So going back to the example, maybe in the future there's an AI daemon that every computer will have. And so, or Kerberos, as you said, the 750 is a security thing. I'm pretty sure. So it's a service. Don't know what part of security it handles. I don't think it's anything to do with cryptography. I want to say it is it cryptography? Well, that's not okay. Passwords. Yeah, exactly. So Kerberos is a computer network authentication protocol that verifies users and systems on a network. So yeah, so probably passwords. It authenticates users without sending passwords over the internet. Kerberos uses a trust broker model and cryptography to authenticate users and so yeah, so it's using cryptography, but its objective it's authentication basically through some kind of a password. It's a daemon that somebody invented and back in the beginning of this, and it's provided. But yeah, good one. Any other questions, guys? So anyway, so the point to understand here, I'm not asking you to memorize those 65,000 entries in here. What I'm asking you is to understand there's Linux. We have desktop Linux that we're using, but there's Linux server. When you deploy it in some data center or something like that, that Linux server is providing a service, right? Such as web hosting. So then you start up a daemon. A daemon is the word for a program that runs in the background in an operating system. We'll cover that in a future lecture. And basically, it's associated with a port number. So the operating system opens a port like port 80. port 443, port 22 if it's SSH, and so on. Does that make sense? So that's really what I want you to understand. Okay. All right. So you can open it with Nano. We opened it with Cat. And then I just wrote find and write down. So you have to, this is your lab, right, guys? So I will provide this document and just a few new problems here. And then just as evidence of your homework assignment this week, just go through this. I know I'm demoing it, but still you need to do it, right? Does that make sense? You have to, yeah, just do a screenshot of things that you did. Just enough to show evidence that you did it. Okay, you don't have to go crazy. So here, for instance, in go to etc services, just I would simply open this and take a screenshot of that. That's it, right? You opened it, you went there, you know how to navigate to open the file, right? That's reasonably okay. And then let's look at the next. Let's go over here. Yeah, bright space. All right, then yeah, you use cat instead of nano. Then let's look at 3. Find and write down the port numbers for the following services. So that's actually what I'm asking you to do. So SSH 22, HTTP, FTP, SMTP, WW, which is port 80, HTTPS, SVN. Simple enough. Go through that file, find the number, write it down. Any questions about that? Pretty easy, right? Right, I did say sometimes in these documents, I just write a comment because I want to, and you don't have to do anything. So this is an example of that. One way to harden a machine is to turn off all unnecessary services. So as you guys know, for instance, a firewall, you all have a firewall in your house, right? And when things initiate from the internet and hit your firewall, they can't get in because all port numbers on that firewall are closed. Same idea, but as you're coming in from the inside out, then it's a different story. Now, if you wanted to SSH from here to your house, what would you have to do? You'd have to open a port at that router, right? In your house, port 22 or something. Right, so that's what this is referring to. Same Linux routers, they're all pretty much very consistent in that way. Services. So now we're going to look at the command called service. And we just want to see, this is another way of looking at what services are running. I like to use netstat and grep and the pipe, but you know, this is another way. So service is running. So let's try out the command service dash dash status dash all. Service dash dash, what was it, status? Dash. See, it's starting to. So it's starting to tell you what services are available on the system. Yeah, go ahead.
Space.
I did it just now. What did I do? Was it in the Word document? Where did you see this? Do you mean something here?
And in like Linux,
Yeah.
instead of everything just spit space.
Oh, it's probably some kind of a flag. I don't know. Like, sorry, but yeah, I see like enter, 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 enter. Yeah, I don't know. I don't know that. All right, so service status all. So we can see services running on the machine, right? This is showing us the UFW. So we'll spend at least one lecture just on UFW. That's the Linux firewall, right? So Linux has actually that's the interface to the Linux firewall, I should say, given that the Linux firewall is called IP tables. So, but yeah, UFW is a firewall related thing, SSH, you know, and so on, right? So these are different services. So that's one command that we can use for that. Let's go back to the document. As you can see here, number 7, to see what services are listening on the network, run the command sudo netstat -l or -n, and then we just take the output of that command and we pipe it into the next command. This is one of the things that I talked about on Monday that I said that was really important, right? Like a breakthrough, or that is basically almost like, think of it as a programming language in the command line of Linux that gives it a lot of power. All right, so here, let's do the first one, sudo netstat, maybe even without sudo, this should work. Netstat, so yeah, I usually run netstat -na, but let's try these different flags. So I'm going to do netstat -l, and you can see it gives me some information, but it gives me a lot of information there is the problem, right? So what you want to do with this is, that's why I run it through the pipe, because there's so much data there. So instead, I'm going to run the same command, but I use this straight line called a pipe. And now all that output that you saw in the terminal will be like sent to the next command, which is almost like a filter. This is the grep command, is a very powerful command that we will look at later as well. And I just want to know TCP related thing, right? All right, so there you go. So this provides a shorter list of things that contain the word TCP in them, essentially. Okay. So that's the idea, and it tells you what ports are listening on the network. So SSH, Telnet, SMTP, HTTP, SSH, and you may not have all of these open. I don't know what you guys have. When you do your lab, show a screenshot of this. Does this make sense? All right, let's do the other one, -n. All right, so nothing came out on that one. Let's see. Yeah, so there's information in there. Essentially just, so a UDP, so that's why I had nothing. So let's clear, run it again. Grep UDP, and you can see it shows that one UDP established connection for the UDP type of packet. Make sense? So there's an established connection there with something. Okay. All right, so I use usually -na. You'll see me do that a lot. And now you can see, oh, and I'm still using UDP. I'm going to change this to TCP. And we have our ports, basically. So this is a good way of like debugging. You want to know if the service is running or something. So I can do SSH is the program. This is the secure shell. So let's say that I have another Linux computer in the internet or something like that. I can connect to it, so I would do like 189 dot blah, blah, blah. But I don't have one right now, so let's just connect to this local machine. And as you can see, it's going to ask me for the password on the user account on that machine. And that's it. As you can see, I have essentially SSH'd into the same computer. Got it? Do you guys see that? But this is really great because if you're managing some, let's say that computer over there, if you're on the network, if you can ping it and that computer has SSH, you can SSH. And it's a totally secure tunnel, basically. All right, I'm going to exit out. And you can see it says connection to 127.0.0.1 closed. Okay. But everything looks exactly the same. All right, so we are out of there. So we saw that. Port 80. Let's see if port 80 Says it's listening. I have 53, 22, so on. Sudo, so let's start a service. Sudo service Apache 2. Start. Okay. No errors. So usually for this kind of thing, starting a daemon or something, you'll probably need administrator privileges. Just makes sense. Apache 2 is like SSH, but not for a secure channel. Instead, it is the web service. Okay. So I started it. So let's now take a look. Okay. So it says that I opened it. So let's see if we have a website. So we go to the browser, 127. You could also type localhost. And there you go. So essentially, I have proven here that Linux, this Linux version is now a web server. Port 80 is open. This is the default page it shows. Obviously, we could go in to var www and change the index page to be. Did you guys get this page or did you get something else? Okay. And that's the case for all of you. You don't have, okay. Yeah, so let me know those things. So if you don't have it, then yeah, go ahead. You're logging in as seed. So then it's the D's password. Does that make sense? Yeah. All right, great. So now we have a use case where you guys, is my understanding, you don't have Apache installed on your system, right? So we're going to go ahead and deal with that problem. I have it, but so what you do is when you're installing a program, definitely you're going to need administrator privileges. So you can do sudo apt. I used to do sudo apt get. I like doing that, but apt works, I believe. So sudo apt get install Apache 2. You guys see that? Just like that. Hit enter. And it'll do something like this, correct? And then you hit Y. And if you get an error, you'll need to do an update. Okay. Right. So then give me a sec. So common things that you need to do is you'll need to do sudo apt update. Okay. But let me just get mine to finish. And then I will provide that command in a second.
Like one more time.
Yeah, I can because it's like installing still, but it should be this one, sudo apt or apt-get install Apache 2. Do you see that one there? That's the command. I guess while it's doing that, I'll just open another terminal. So for those of you that got an error when you tried to install, that's a common thing. So then you just do sudo apt or apt-get update. You see that? And just hit enter. And that usually will update the repos in your system and then repeat the installation command and see if it does it. It works, right? Yeah. So that's a nice solution. It just updates the repos, everything. All right, so it's finished for me. So then it probably wouldn't hurt that I do that too. So yeah, you don't have to do this every time, but you know, if you're just starting the computer for this semester, do the update. Any questions? All right, so it finished for me. So now, usually, once you install it, actually, when you install Apache, it actually starts the server. So you guys should have it now. So go ahead and go to open a browser and just type in localhost or 127.0.0.1, refresh, and you should now get a page that looks like this. Yep. All right. Excellent. Everyone got it? All right. So that's services. There you go. We explored two services, SSH. We SSH into ourselves. You saw that that's associated with port 22. Boom, you made an SSH server. Or a more useful case, you have a data center, you're going to build your e-commerce solution, sell your products. So you need to have a website. Boom, you get Linux, install Apache 2. That's it. And then as far as the website, the place, in the file system, there's a folder called var, which is variable length. That's kind of what it stands for. So websites can grow, right? So if you're building an e-commerce solution, you could use PHP, MySQL, boom, it becomes really big. The LAMP stack, essentially. So it's a variable length kind of a website. Plus, what if you have a lot of images and things like that, right? So it's variable length in size. So everything goes into that folder, essentially, var, which is the one I'm currently at, Pw.D. Then you can do ls-l, and you can see here, we can look at the libraries. We got mail, it's important. Log files usually end up here as well. And then you can see we got our ww. So you want to do ww, clear, ls-l, HTML. You guys, of course, know what that is. We go into HTML. And then there's the index page, HTML, and so on. So you can do cat on this one. Oh, yeah, sorry, what am I doing? It should be, or it should have a reference in there to something. So let's take a look. So so here's an HTML page. It says modified from the Debian original body. Got a whole bunch of, pardon? Yeah. So I'm just going through it. You got to find the body of it. Apache 2, it says over there, conf in an li. So what is something? All right, here's the head section. Here's the title, Apache 2 Ubuntu default page. It works. Okay. So let's go to the browser. There it is. See that, guys? That it says in the little pop-up, Apache 2 default, it works, something like that. We also see Apache 2 Ubuntu default page as a heading. So that's gonna be and yeah, that's what I'm trying to do. Yeah, but permissions. Check the permissions first before you do a lot of work. So I'm trying to find. If you guys find it, let me know. Oh, here it is. Body. Okay, so Apache 2 Ubuntu default page, right? So this one should be that same thing that we were looking at. I want to say. So let's add in there. Oh, I opened it with cat probably, so that's a problem. So let's then do ls-l and let's work smart. So this is owned by root, and only root can write. You guys see that? What do we do? How do we solve this problem? Just sudo it. Okay. So now sudo nano, because we need to modify, not just view, index.html. Okay. So now we've opened the editor. So now let's scroll down and find that place. It's around here, right? Yeah, here. So I'm just gonna add the word blue, Control X, yes, enter, no errors. So we were able to edit it. So let's go here. There you go. Did you see that? Change the word to blue. Got it? So here's permissions. You have to go to the var ww, but if you put this thing in the web, you got a website, and you turn that Linux server into an Apache web server, and it acquired that property just by starting Apache 2 and so on. That's it. All right, so that's kind of like the gist of today. So let's go back to our document. So we did this, open a website, right? Sudo netstat grep TCP, close the website. So do that. And the point with this is that it's going to show that you've established a connection to the website. Okay. So that's, do you know what I mean? Like if you go to the command line, oops, the command line here. Let's close this because we don't need this. And actually clear that. So netstat, where's netstat? Netstat dash NA pipe grep TCP. Okay, so you can see a lot of this is just listening. There's a couple of connections that are time wait, but none of these are established. If we go to a website, we're using TCP, correct, to connect to that website, which means we're going to do the three-way handshake, which means we're going to establish a connection. And we can see those established connections here, okay? If somebody is doing a denial of service attack on you, then that means they're initiating a three-way handshake, but they're not completing it. So you're going to see hundreds, if not thousands, of entries here that say something like connection initiated but not established. And that's the denial of service attack, for instance. But in this case, let's kind of try to change this from and create an established connection, right? So something like going to a website, for instance, unless you guys have a better idea. So I'm going to go to www.lsu.edu. All right, so we're just making a connection with some website. Just go to any website that you like. All right, so now let's take a look over here. Same. Wow, look at all those connections. You see that, guys? Just by visiting a website. Why so many connections? Because websites nowadays have advertisements, have a thing that goes to click something or adware, or lots of connections are created. And they say establish, if you notice. So you've actually completed the three-way handshake. Any questions on that? All right, great. So let's move on. So I think you get the idea of netstat, right? So pretty important and powerful tool. I'm going to close the website here. All right, so I think you get the idea with these. So I don't think I need to do all of them, but you need to do these. All right, so close the website. What do you notice? What does netstat-nr show? So run that command. Route, this shows you the routes that you have established on the operating systems. Has to do with networking. So take a look at those. Netstat tab UAP grep listen. So this basically, as I said, grep just whatever input it receives, it looks for that keyword, right? So in this case, you would be looking for ports that are open and have the word listen on that row. So then what is grep? So I've alluded as to what it is. We'll do this in another lecture in the future. Some flags and ways of using grep, but just for now, just on Wikipedia, just search and provide 2 to 3 sentences on what you think grep is. Does that make sense? Yeah. But it's a very powerful. Grep and awk is an actual topic that we're gonna discuss later. All right, display all active processes. What is PS, this one? So let's try that one. So PS space AUX. So PS, processes that are running, and the PID. So I'll talk about all this when we talked about set UID, but basically any processes that you have running in your computer are going to appear here, PS dash UX, right? So it shows you more information. As you can see, start times and so on. So if we start a program, oh, let me exit out of here. Let's go back to, let me actually close this terminal. Okay, let's go to desktop. And 72, spring 20, oh, 2025, there. All right, we have a program here. So let me do PS, right? PS. Now I want to start another process. So let's do hello world. Okay, it ran. PS. Doesn't show it. I think we need to have it running in the background. So let me do while true 1, 2, 4, A equal 3. So I'm just going to create an infinite loop so that this process is running in the background. Does that make sense? All right, so Control X. See, it did that, but it's still there, right? Still there. So obviously I don't want to kill this terminal because if I kill it, then the program will stop. So I'm going to try creating another window. Yes. Okay, so it's not showing. Maybe. Yeah, maybe that's actually a good idea. So let me go back to it. Clear. Python. Okay, it's running. Let's try it. I'm trying to create a process. Well, I think the process is actually bash now that I think about it. That's what it is. So see this bash here is actually where I'm running it, right? If you think about it, I opened the bash is the terminal. So then let's do an experiment. So you can try to get to that other. Because it's in the loop, it's making my program more sluggish. All right. Yeah, can't. All right. So as you can see, it's not letting me. So what I'm going to do is I'm going to repeat it, but it's basically bash. So what I need to do is I can still type here. It's just pretty slow. So I want to stop that program that's running in the background. Whenever you have a piece of software and you run it, it basically becomes a process. It gets a process ID and it's running in the background, right? So you can see I type and it's taking a while. So what I'm gonna do is I'm gonna kill that process basically by killing the process ID that you see there, that 32101. All right, so give me a second. It has become pretty terrible. Okay, so I'm kill dash 9 32101. I think I added an extra 2. 101. Let's give it a minute to catch up. Okay, does this make sense? So now I ran that. This one is still running. So I guess I killed that terminal. Hmm, this is not working. Yeah, I killed the other terminal, not this one. Yeah, I guess this is a bad example. I'm just gonna kill it this way. Um, yeah, yes. See, there they are. Now they appear. Okay, so that's what I was trying to do initially, right? So to create the Python programs, um, PS, they're there. So I was trying to get rid of them. So kill dash 9 32090 killed. Okay, so I do PS. It's gone, right? Do you see that? Now I'm going to repeat it. Kill dash 9 32170. Okay, PS, and there we go. Do you see that? So when sometimes you have a process, you're running something and um, it's slowing you down or whatever it is, you can use that command to kill a process, but you have to do it by process ID. Go ahead. It's the flag. So I don't remember exactly. It's always used. So we can do kill, maybe dash help, dash help. Okay, so this provides some info. Kill is a shell built in for 2 reasons. It allows job IDs to be used instead of process IDs and allows processes to be killed if the limit of processes that you create is reached. What's that? If I type what? Just kill? Did you find what the 9 is there? Like this one? Yeah, his question is what does the 9 do exactly? So it's a flag. I was looking for that. I mean, we can Google it. I just essentially just used that. Take a look. So what does the 9 in kill Linux. Yeah, so the kill -9 command sends a sig kill signal to a device, shutting it down immediately. What does denied? Okay, so let's see. Yeah, so it's pretty similar. So -9 just means kill or sig kill, basically. Um, cannot be blocked, possibly. So kill -9, and the description is, I guess it's just like a very terminal kill, like cannot be stopped. Um, Yeah, so the kill, so basically here's an explanation. So the command kill sends the specified signal to the specified process or process group. If no signal is specified, the term signal is sent. The term signal will kill processes which do not catch the signal. For other processes, it may be necessary to use kill 9. Uh, so using -9 switch ensures that the process will be killed. So it's like an interrupt or something in hardware. It's just definitive. So some process may be more complicated to kill. But yeah, so it's kind of like when you have a problem and you want to get rid of a process, just run that. Right? It's not something that you use all the time, right? So in fact, you shouldn't have to use it. I basically have used this when I'm running like something with a GPU that's like processing, like for data science or something. And then somehow that process of the GPU is still stuck doing something. So I want to clear it out to clear out RAM memory on the computer. So it's kind of like that. All right. So let's keep going. It's one. And I want to do some scripting as well. So you guys we'll do the rest of these examples, but I think it illustrates the idea. So look at NPS. So these NPS is for looking at processes. We have a process in the background. And I can kill command. Search what these commands are top, right? So for looking at processes. R is the R table, which I'm sure you've learned about in your networking classes. So you can take a look at that. SSH, it's installed, and we already did this actually for web, so you have an idea of what that is. You don't have to use PuTTY. You can skip it. PuTTY is a Windows SSH utility. Carry out a port scan on your machine, so Nmap. Nmap is I'm sure you've heard about Nmap. It's just looking at ports on different machines. And if it's not available, install it and then run it, and the output should be a list of port numbers. Does that make sense? Kind of consistent with looking at services and service numbers. So that's Nmap. Yeah, so that's basically it. So let me take a look at these problems that I had before. Create a file called temp, regular user, using the numeric notation, change the file permission so that only the owner can read and write to the file. Okay. Yeah, these are problems I've done in the past. Create a file called temp, using the numeric notation, change the file permission so that everyone, okay. Create a file called temp with regular user. Create a Python script that makes it executable. Create a Python script. Yeah, so I like these problems, actually. I think I'll leave some of these and I'll just change a couple of the coding ones. And this will be your homework assignment for this week. Does that make sense? So these are kind of related to what I did on the quiz, right? On Monday. So let's read the first problem carefully. It says, so the homework, again, I'll repeat, is all these problems from 1 through 40, right? Just do it as I've been demoing. And then the problems, it'll be 5 problems, which are these. I'll probably leave the first three and then just change the coding ones a little. Got it? So I'll update this file. Yeah. I'm gonna do it like in class today. So it should be. We still have like 30 minutes. So let's look at problem one, right? So just so that we're in agreement that you guys are working on this one, create a file called temp.txt with regular user. When I say something like regular user, I just mean seed without the administrator privileges, okay? Using the numeric notation, which I showed you on Monday, so you need to show that command, change the file permissions so that only the owner, that is seed, can read and write to the file. Do you guys understand? So it's read W, no X, and then all the other ones are blank. Got it? But calculate the number notation. Any questions on problem one? Excellent. All right, let's look at problem two. Create a file called temp.txt with regular user, seed. Using the numeric notation, change the file permissions so that everyone can read and execute the file. Only the owner can write to it. So it's read WX, then what? Read X, right? Everyone? Yeah? Any questions? Yes, sir.
Do we need to create a new file for every problem, or can we say one?
Yeah, actually you can, right? Because all that matters is the final outcome. Yeah, so that's, yeah, you can do that. All right, so problem two is clear? Great. Problem three, create a file called temp.txt with regular user. Using the numeric notation, change the file permissions so that owner and group can read, write, and execute to the file. Everyone else can only execute the file. So that means read, write, X, dash, dash, X, correct? So you do the computation for that. All right, create a Python script that make it executable using the numeric notation. Change the file permissions to, okay, root on and say, yeah, we haven't covered this. I'll cover this next week. So I'll change this problem because I haven't covered set UID and I'm not going to cover it today. So I'll change problem four. Problem five, create a Python script and make it executable. You can do that. Now create a symbolic link to it. And then run the Python script using the symbolic link. I think you can do that. You'll have to figure out how to do it. But it's a command. It's ln, I think. ln space -s. And so you'll create the executable file. When you do ln-s, you create a name and you tie that name to that file. So essentially you run that name and you're running the code because they're linked symbolic. Okay? So I'll leave that one to you guys to play with. Okay? And try to solve it on your own. And we'll talk about it next week. So now that I'm gonna change, I may add maybe two more problems then that are Python related. So let's now switch gears, okay? So we've spent a bit of time just on Linux commands. Now we're gonna switch back up to Python. And yeah, and I think I know what problem I'm gonna give you. Okay, so any questions on this one, right? So at this point, the only one I'm changing is 4, and you're responsible for the whole thing. Got it? All right. But I will be updating this document. So let's go back to the module here. So you can see we did all this. I will add a link here. Actually, I can do that now. And I'll just say using this Word document here, right, as your homework assignment. Do you have a question? Huh? The cuckoo's egg, yeah, that's what I was gonna do. That's probably the fourth problem I'm gonna add or modify. So let's go ahead and click on new assignment. So this is your homework. So I'm gonna say homework. I'm gonna call it services, okay? Which basically means what we did today, services. And I'll say something like Python, okay? And 100 points. the date to, this is due. So today's the 29th, right? So this will be due on the 5th. Okay. So it's open now, and it'll stay open until the 2nd. No, sorry, 5th. So the 9th. Does that make sense, guys? So that's the hard deadline. If you miss that one, that was your last chance, okay? But try to submit it by the 5th. Any questions? All right, excellent. So now let's just add a description that we can all agree on. Complete. All the steps and problems in the attached Word document. When I say attached, sometimes I don't mean attached here, but in the module itself, right? So complete all steps and problems in the attached Word document, i.e. in the module. All right, so complete all the steps and problems in the attached Word document. Is that clear enough as a description of what you need to do? You know what Word document I'm referring? There's only one in it. Any issues? All right, excellent. So I'm going to click on that. So the homework assignment has been assigned. So let's take a look. So services and right there you have it. If you look, there's a link, PowerPoint, a PDF. There's only one Word document, and that's the one that you're responsible for. And I will be modifying it in a sec just to add the Python scripting problem. All right, so we're done with Linux commands for today, and that now we're going to look at some scripting. So that's the previous module. So I'm going to go back to scripting in case. I will not be adding a homework link in this module, right? So it's in the next one. But let's take a look at where we are here. So I provided this background on software, processing text, files, etc. That's just a whole bunch of random Python syntax. Take a look at it if you'd like, or find your favorite Python blog. All right, so you can skip this document if you want. All right, here I had the cuckoo's egg, which is probably what your homework is going to be, which we had discussed last week. So I think this is the case itself, which I've already read. Yeah, so I'll leave to you guys to read this again. But essentially, you're building write a Python script to address the case. You do not have to use the actual passwd and shadow file. So what are you building? A password cracker, right? Everyone with me on that? That's going to be most likely your homework assignment. Okay. All right. So this case, let me just take a look at this document here, lab intro, Linux scripts. I want to see because I had started this, I remember last week, but I don't remember if I finished it. So lab content. So write a Python script to gather 10 pieces of information from the operating system, i.e. metrics, such as users logged in, RAM usage, CPU, GPU usage. You can do the following. Okay. As discussed in class, write a script to iterate through the entire file system and find the path. Write a script to read the passwd file, search its contents, and print out information related. Okay. And port scanning script. We did the port scanning, didn't we? Weren't we? I think we got, we did it, didn't we? I thought we did that one. Let me take a look at, so we're in the folder. Basics Python, probably. What's that? Yeah, run commands, socket example. So at socket example, I think. The socket. There was an error. Print. Yeah, scan sockets. I don't remember if we connect. We got SSH, I think. I can run this one again. So we'll need sudo python. Okay. An error. What was the port number that I had it? Well, we can just do 127.0.01. Don't we? Didn't we just do that today? Did I really? For 22. There it is. So CSSH works. So we're able to get that banner, which I think is what we had done the last time around. Does this make sense, guys? So that's essentially, we'll spend more time when we look at Scapy. Scapy is a much more powerful library for this kind of thing than say this. So, but essentially we took an IP address, the local host 127.0.0.1, and we scanned for port 22, and this is what it returned. It's like the banner of that service is just saying the version of SSH that we have installed. Does that make sense? So that was just part of the basics. Okay. All right. So I'm not going to take it further than that for this one. So that's the port scanner that I wanted to cover. This one, number 4. I'm sure I showed you how to use subprocess.call. This is very nice feature. Oh, sorry, my battery's low. Give me a sec. So we're just gonna do the cuckoo's egg. I don't want to give too many. Here we go. All right, so iterating through the file system. We'll do that later with OS. Write a script to read past contents. Yeah, this is the cuckoo's egg. All right, so essentially then, let's just focus on that one. So solve the attached cuckoo's egg case. That's what I'm about to do. Exactly what I'm copying it. Okay, so disregard this one. We did it in class mostly. All right, and I'm going to go now. I'm going to download the case itself. Download. Just did that. I'm going to go to the table of contents. So notice, in this folder, there's no assignment, so there's nothing to submit, right? You understand? So we just did it in class. The homework is in this one for this week, services, here. And I'm going to download the Word document, this one, I believe. Okay, now I'm going to go to my folder over here. Downloads. Okay, it's taking its time. So here's the cuckoo's egg, and this is probably the homework assignment. Let's open that one. So all this is what we covered today. Set UID, I'm changing. Or to solve the attached cuckoo's egg case. Got it? And then 5, create a Python script and make it executable. Now create a symbolic link to it and then run the Python script using the, yeah. So I'm going to leave that to you guys to kind of figure out on your own as well. Any questions? All right. So you only have basically one Python script to do, which is this one, number 4, and then 5 is just a Linux command. And then the first 3, which were the numeric notation for chmod. Questions on any of this? All right, so let's go ahead. I'm going to save this. So now I'm going to re-upload these files to Brightspace. So I'm going to delete this one. Download. It's going to be this one, this one. All right. It's a new feature in Brightspace. All right, so I think I've added the file. So let's confirm. So table of contents. So the cuckoo's egg, of course. That's just there again. Have to read it and build your password cracker. And then the lab services document, which is the document that you have to complete. So all these bullets. And then you can see number 4 has been changed to solve the attached cuckoo's egg case. And that's it. That's homework for a week from today. Any questions on any of this? Clear? Everyone with me? All right, guys, work on this. And so I'll stop the recording here.